Hello students, I have already uh, uploaded the lecture of October number 2019 33 from question 1 to 4 in my earlier lectures. Now I want to deliver question number 5 to 7 in this lecture. Question number 5 is related to the draw graph of suitable graph shown in the equation ln of x plus 2 is equal to 4e power minus x. You should only draw the graph without taking the tables, or it's very convenient if you draw the tables of these two functions separately. First, I suppose that ln of x plus 2 is equal to y, and then y is equal to 4e power minus x. I take some values of x and derive some values of y for graph ln of x plus 2 and graph for e power minus x. Hence, I draw these two graphs which cut each other at one point only. In second part, he is asking about that prove that the solution is lies between x is equal to 1 and x is equal to 1.5. It's very easy part. First, I simplify the equation ln of x plus 2 minus 4 e power minus x is equal to 0. Then put x is equal to 1 in this equation. I find that first value is minus 0.3729, which is less than 0. And again I put the value of 1.5 in this equation. I get that 0.36, which is greater than 0. So it means when there is a change of sign, then it means the solution is lies between these two points. Hence prove that the root lies between 1.5 and now, part number 3, it's the iterative formula. You should find the values by using iterative formula. Determine the roots correct to two decimal places. Give the result of each iteration to four decimal places. You should take each iteration till four decimal places. Otherwise, your question is wrong. First, I derive the first value x1, which is taken from the previous part. I have found that the root lies between 1 and 1.5, so I suppose that the middle value is the root. I find middle value 1 plus 1.5 over 2 is equal to 1.5. I put this value in this equation and find the value of x2 is equal to 1.1609, and then put this value in place of x. I find the value of x3, then similarly a value of x4 and the value of x5 and x6. I have found that there is 3 time repetition. 1 point x4 is equal to 1.2230 and x5 is equal to 1.2290 and x6 is equal to 1.2274. I see that there is a two repetitions or three repetitions. So finally I find the value 1.23, a round of 9 and 7, and I find the value of 23, 1.2. This part is related to the complex numbers. It's a very easiest part. Question use of calculator is not permitted here. The complex number with modulus 1 and argument pi by 3 denoted by w express w in the form x plus zeta by a complex number where x and y are real and exact. It means w mod modulus is equal to 1 and alpha angle is equal to pi by 3. This is the polar form of the complex number. Polar form is w is equal to w modulus into cos alpha plus iota sin alpha. I should change this polar form into Cartesian form. I applied the value of w modulus is 1 and angle pi by 3, and hence I find the Cartesian form of w is equal to 1 by 2 plus iota under 3 by 2, which is required form of complex number. In third part, he is asking that the complex number 1 plus 2 iota is noted by u. The complex number v is such that v modulus is equal to 2 modulus u and argument of v is equal to argument of u plus pi by 3. Sketch an Argand diagram showing the points representing the u. First, u modulus, I find the u modulus. U modulus is equal to the square of real number 1 and the square of imaginary number 2, it will become under root 5. And V modulus is equal to 2 times of modulus of u. So, V modulus is equal to 2 under root 5. Argument of u, I find that tan inverse of imaginary part 2 over real part 1, it will become 1.107 in radian form, because he is asking in the form of pi. When the angle is in the form of pi, we should take values of angles in radian only, not in degree. So argument of u is equal to 1.107 radian, argument of v is equal to 1.107 plus pi by 3 according to requirement. It will become 2.15. First I draw u argument, u complex number, angle is pi by 3 and it is the points on x-axis is 1 and point on y-axis is 2. In the same way, I draw the complex number v whose angle is 2.15. It means greater than pi by 2. Pi by 2 is 90 degree and is greater than, it lies in the second quadrant to 2.15, and its modulus is 2 times than the modulus of u. I draw estimately the modulus of v is 2 times than the modulus of u. In next part, he is asking about v can be expressed as u to uw, hence find v, giving your answer in the form of a plus w, where a and b are real. In order to prove that v is equal to 2uw, first I find the argument of modulus of u is equal to under root 5 and modulus of w is equal to 1, which is given in part 1. So 2 modulus of uv is equal to 2 times modulus of u into v. It will become 2 under root 5, which we have already proved in second part, that modulus of v is equal to under root 5. So modulus of 2 into uw is equal to modulus of v. This is the requirement. Argument of 2 uw is equal to argument of u plus argument of v. In the product, when the modulus is the product, then we should add the angles of this. So it will become equal to the argument of v. And we find the v. V is equal to uw, 2 times uw. First I find the product of u and w. The real part, first real part is multiplied by the complex number w, 1 by 2 and iota under root 3 by 2, and then 2 iota is multiplied by 1 by 2 and iota under root 3 by 2. Iota square is equal to minus 1, so that's why it will become 1 minus 2 under root 3 by 2 plus 2 plus under root 3 over 2 iota. I separate real and imaginary part. Then multiplied by 2, it will become 1 minus 2 under root 3 real part and plus 2 plus under root 3 iota imaginary part. So final answer of V complex number is 1 minus 2 under root 3 plus 2 under root 3 iota. Now, question number is, next question is related to the vector form, equation of plane and equation of line, something else. Here he is asking about the equation, the plane M has equation x plus 4 y minus 8z is equal to, the plane N is parallel to M and passes through the point P with coordinates 5, 2, minus 2. Find the equation of N, giving your answer in the form this. When M and N, these two planes are parallel, it means the direction of both planes is same. The direction of plane M is 1, 4 and minus 8. Has a direction of plane N is also 1, 4 and minus 8. But the point of the plane N is 5, 2, minus 2. We applied the formula here. R dot N is equal to A dot N. R means the coordinates x, y, z, and N means direction of plane N, and A mean point of plane N, and the N mean the direction of the plane N. So R dot N is equal to A dot N. Hence I simplify this, then it will become x plus 4y minus 8z is equal to 29, which is the required equation of the plane. In second part, calculate the perpendicular distance from M and N. I explained here formula. Perpendicular distance of plane from origin. Any plane from origin is ax1 plus by1 plus cz1 plus d. It means a are the coefficient which is in the plane M. Coefficient is x plus 4 y minus 8z. A is 1, B is 4, and C is minus 8, and D is minus 2 for plane M. We are finding the equation of distance of these planes from the origin. So x, y, and z in both planes should be 0. So distance of plane M from origin is 2 by 9, and distance of plane N, sorry, not here M, it is N. Distance of plane N is 29 by 9. The negative sign will become positive when it is right without modulus. So this perpendicular distance between two lines, because we have finding the distance of these two planes from origin, it means the distance between these two planes are, when we subtract these two distances from each other, it will become 27 over 9, it equal to 3. In next part, plane N passes through the point P and is perpendicular to OP, where O is the origin. Find a vector equation for uh, basically for L. Now line L lies in the plane N. P with coordinates 5, 2, minus 2. Equation of N is x plus 4y minus 8z is equal to 29, which we have found in previous part. Equation of OP is 5y plus 2j minus 2k. Because it has only direction, because equation of line L is starting from the origin at one point P. So its directions is 5, 2, minus 2k. So direction of line L is N is equal to N1 plus N2. N1 is the direction of OP and N2 is the direction of the plane N. Here I use cross product by using simple matrices method. N is equal to, N is the direction of the line L. I, J, K, first N1 is equal to 1, 4, minus 8, direction of equation. The direction of equation of N is, then the direction of OP is 5, 2, minus 2. I into hide the column I, 5, I1 and 5, J, K, O, and take the matrix 4, minus 8, 2, minus 2, then minus J, hide the column J, 4, 2, and row I, J, K, and takes a matrix 1, 5, minus 8, minus 2, and find J. Final plus K, hide the column K, minus 8, minus 2, takes the matrix 1, 4, 5, 2. In this I find that 8I minus 38J minus 18K. When we take 2 common from this equation, it will become 4I minus 19J minus 9K. It's the required direction of plane N. You should also take the direction 8I minus 30J minus 18K instead of 4I minus 19J minus 9K. So equation of line L is, point is 5I plus 2J minus 2K, which is the P point, plus lambda 4I, which is the direction of line L, 4I minus 19J minus 9K.